Hi, welcome back to day 3 of similar triangles. We are going to look and try this method to figure out yes, the triangles are similar, or no, the triangles are not similar. And what we have to do here to determine that, doing the long method, is to compare all the side pairs, see if they're proportional, and compare all the angle pairs to see if they're congruent. This is the long way. This is setting us up for being able to use shortcuts because it's unrealistic to think that we're always going to have every piece of information about a polygon. But let's do it this way. That way you'll understand why the shortcuts exist. So first we're going to compare the corresponding angles. So angle N, you guys can see that, has one arc mark. And if we look at the triangle on the right, angle R has one arc mark. So that's a congruent pair of angles. Angle Q has two arc marks, and so does angle S. Now, because triangles add up to 180 degrees, and we have two pairs of congruent triangles, it doesn't matter what these angle measures actually are. If I added up angle N and angle Q, I would get the same thing as if I added up angle R and angle S. So when I subtract that from 180, I'm going to find out that angle P and angle T are also congruent because we already have two angles in each triangle that are the same. So that part's pretty simple. Now, step 2 is a little bit tougher because we have to do proportions, and proportions are just a little bit more work than saying, hey, this side is the same length as this side. And the reason that it's more work is because we have to figure out which sides are the small sides, the medium sides, and the large sides before we can even write a proportion or a ratio. So first what I'm going to do is I'm going to look at the big triangle and then I'll look at the small triangle. The big triangle has a 15, a 12.5, and an 11.5. So I'm going to label the 11.5 as the small side, the 12.5 as the medium side, and the 15 as the large side. And that's just based on their numbers. 11.5 is the smaller number, 12.5 is in between those two numbers, and 15 is bigger than both of them. And then I'm going to do the same thing over here. Let's see, the small side is 9.2, the medium side is 10, and the large side is 12. So you have to be really careful about that so that you get the correct side pairs put into a ratio with each other. So now what I'm going to do is I'm going to set up a proportion. First, my small one. I'm going to do 11.5 to the other small one, which is 9.2. Then I'm going to do the medium. So let's see, I'll have 12.5 if I take the triangle on the left, and then 10. Okay. And then I'll do the large. So 15 is the triangle on the left, and 12 is the triangle on the right. Okay. So without a calculator, I might be able to do some of this in my head, but I'm just going to go ahead over to Desmos and check out their simplified fractions. So let me delete this out. The first thing we have is 11.5 divided by 9.2. And we have 12.5 divided by 10. That's probably one that most people would be able to do in their brain, maybe. And then 15 divided by 12. And what I'm going to do is I'm going to look at each one of these and see, are they the same? And they are. They're all 1.25. And if I change those to a fraction, that gives us 5/4. And so I'm going to write that down, 5/4. Sorry about that. So that means that these two triangles are in fact similar because their sides are proportional. They all have the same scale factor and their angles are congruent. So I know the scale factor is 5/4, but now I have to write the similarity statement. What I typically do with the similar triangles, if I know the angles, I use that information for writing the similar triangles statement because it's just a lot simpler than dealing with the sides. So here I would have triangle similar to a triangle. So I would have N and R. I would have Q and S. And I would have P. Oops, that's supposed to be a T. Looks like an F. One sec. There we go. And T. So I would have triangle NQP similar to triangle RST. And that's what it looks like to do every single comparison that is possible. That's what I call the long method. And sometimes we just aren't given all of that information. Sometimes we have to use some shortcuts. Just like we did with congruent triangles. When we use the shortcuts, some of the information is shown in the picture, but it is not marked. Remember, in congruent triangles, we had shared sides, we had vertical angles. Let's just remind ourselves of vertical angles. That should be an A. They are congruent, even though they're not marked. We would mark them ourselves. And then with a triangle like this, and I think you will remember that in triangle congruence, we had to occasionally separate the triangles. Well, I'm going to have to do that here as well. Hopefully you can see that the small triangle is actually sitting inside the big triangle. So I'm going to have to separate these guys out. So I'm going to take out the small triangle. I'll have D, B, E, and then I'll draw the big triangle separately. That'll be A, B, C. And if you notice, they still have angle B in both of them. And that's because of this. Angle B is in both triangles. And that's because of the reflexive property. You'll also have that with shared sides. So that's something to consider. When you're looking at triangles, you need to make sure that you're marking everything that you know. Just because this is not marked does not mean that angle B is not the same size in both triangles. And that just might be the piece of information that you need to work with similar triangles. All right, I'm going to stop it there. And in our next video, we'll be on page 14 and we'll be talking about some shortcuts.